Now that we love what operators can do for us, let's use the NuoDB operator to start a NuoDB SQL database. Inside the operator are all of the smarts needed to start a user configurable NuoDB database. We just need to ask for it. In our shell window to the right, let's quickly review the CR-YAML. This is the custom resource file that we're going to use to tell the operator to provision a NuoDB database. You can see there are many options that are available, so you can finely tune and customize the database that will be created. Just quickly reviewing some of the options, we see that you can modify your storage mode. You can choose persistent or ephemeral, or you can choose to enable the NuoDB Insights visual monitoring tool, which we'll talk more about in this presentation. And there are other various options available, choosing the number of pods that you would like to run of each NuoDB process type, along with memory and CPU allocation, so you can build a database that meets your application requirements. The next step is to run a program that will run this CR-YAML file. I've called my program Give Me a NuoDB Database. Let's go ahead and run the program. And we can see already the NuoDB processes have appeared to jump or leap right out of the operator. We can see that the operator is busy provisioning the database and is starting processes of each type: the transaction engine, the admin, and the storage manager. A NuoDB database is a collection of these three different process types. An admin is responsible for creating a management domain across physical hosts that can support several logical databases. A storage manager, which we call an SM, which is responsible for making transactions durable to disk. And a transaction engine, which we call a TE, which is an in-memory database cache responsible for processing SQL transactions on behalf of the client application. The database will be fully available as soon as all of the pods start, but it only takes one pod from each process type for the database to be active and available, which we can see is already the case. We have one process of each, and we've asked to provision 3 admins, as we saw in our CR-YAML file. We've already started 2 of 3. NuoDB also allows you to create a highly scalable and fault-tolerant system simply by configuring multiple of each process type. If any process should fail for any reason, it's okay. There are others of the same type to pick up the load. The result, your applications are continuously available because the NuoDB database never goes down. The database is now fully configured to the desired state that we asked for: 1 transaction engine, 3 admin processes, and 1 storage manager. Next, let's go ahead and start that NuoDB Insights visual monitoring tool that we mentioned earlier. We can do that by selecting pods on the left, and we'll see all of the pods that were started during the provisioning process. Scrolling down, we can find the NuoDB Insights pod. By clicking Logs, we'll find the link to NuoDB Insights for our deployment. I've selected the link. I'm going to paste it into a new window, a new browser window, enter my credentials, and now I have a visual monitor, NuoDB Insights, that is monitoring my database deployment. Let's go back to our project, and the next step would be to start a sample SQL application to generate load against our database. We can do that by finding the YCSB load application that also started during the provisioning process. We can simply choose Edit Count and start a couple SQL applications. This sample SQL application will first insert 10,000 rows into the database, and then it will run a number of SQL connections against the database in a continuous fashion, generating a constant SQL load according to the parameters. Again, you'll notice in the CR-YAML file there are a number of YCSB options that allow you to configure just how much and the type of load that you would like for your sample application. Let's go and check on NuoDB Insights. And we can see that we have one transaction engine running, one storage manager, and our transaction load is already starting. I'm going to select last 5 minutes, and we can see that we're already running an aggregate of about 800 transactions per second. By clicking the SQL panel, we can see by scrolling down, here's where the rows were inserted that I mentioned. They were inserted at about 700 per second up into installing a full 10,000 rows, which then over in the middle, we see the rows updated that the SQL connections are already connecting to the database and running sample statements at a rate of 432 updates per second. Going back to the SQL overview, we can see already that we're starting to baseline around 6,000 transactions per second. Now that our database and visual monitoring are both up and running and SQL statements are being processed, let's have some fun showing some of the NuoDB superpowers and benefits, starting with ease of scalability. As your applications require more or less SQL transaction throughput, NuoDB can be dynamically adjusted to meet those requirements at runtime. Unlike other databases, NuoDB's transactional and storage tiers scale independently of each other, a core tenet of NuoDB's container native properties. We can demonstrate this easily by adding more application pods, which generates an increased application workload, and then respond by scaling out the NuoDB transactional layer to meet the additional application demand. So let's go ahead and demonstrate this. We'll go back to our YCSB application pod, and if you recall, we were running 2 applications. Let's go ahead and increase our application load. We'll double it. And while those pods are starting, let's go back to our transaction engine and increase the NuoDB's capability to process more SQL. We have 1 pod. Let's go ahead and increase to 3 transactional pods, giving ourselves 3 times the transactional power to now handle the increased application load. If we go back to NuoDB Insights, we'll watch as the new additional YCSB pods add additional load to the system, and the additional transaction engines are added to the system. You can reconfigure Insights and customize it to refresh more frequently simply by changing the refresh interval from 30 seconds to 10 seconds. We'll soon see Insights update to reflect that we now have 3 transaction engines, which is now just updated, and in the lower center area where it says aggregate transaction rate, we can see that we were baselining nicely around 5,000 transactions per second. But the yellow line is indicating that we had 1 transaction engine, but then we increased to 3 transaction engines. You can notice that we added more SQL workload, but at the same time, by adding more transaction engines, we were able to increase our net transaction rate per second from about 5,000 all the way up to what looks to be near 10,000 transactions per second, simply by adding more transaction engines to our database configuration. That concludes the scale-out portion of the demo. Stay tuned for the next segment on resilience. To learn more about NuoDB, visit www.nuodb.com.